Okay, that's good. Mass flow. Now, before I do mass flow, let me just turn it. I'm going to put in a special thing here. When it comes to flow meters, there's something we're supposed to do, which is called sizing the flow meter. We're supposed to size the flow meter. When we buy a flow meter, we're supposed to size that flow meter so that it's correct. Now, there's a problem with sizing flow meters. Well, there's not really a problem with sizing flow meters. It's easy enough to do if you do all the calculations and you work out the Reynolds number. The problem is, so here's my flow meter I'm buying. Here's my flow meter, and I'm supposed to size it. My problems arise from things like cost. If this flow meter costs, say, $100,000, which is not an unreasonable amount for a flow meter to cost, a biggish flow meter, then that's quite an investment. My problem comes from the fact that if I stuff up and I size the flow meter wrong, if I size the flow meter wrongly, then I turn round to the suppliers and I say, "Oh, I'm awfully sorry, supplier. I sized the flow meter wrong. Would you mind taking it back and giving me another one, say the next size down?" Now the supplier will say, "Certainly, that's not a problem. I'll take it away and give you another one. And by the way, the standard restocking fee." The standard restocking fee will apply. And the standard restocking fee is 15%. So the salesman comes along and he picks up the flow meter which I bought incorrectly, and he takes it away in his car, and he puts it in the shelf in the warehouse, and he brings me a new one. And it costs him absolutely nothing, but he charges me 15% of $100,000, which is $15,000. That's a bit of a problem. So, my recommended way of sizing flow tubes, my recommended way of sizing any piece of equipment that costs a lot of money is not to. You don't do sizing. What you should do instead is you should get the rep to do it. That's what the rep's job is. So rather than size it, risk making a mistake, and end up wearing 15% restocking fee, when it comes to flow meters, the best way to size a flow meter is to phone the rep up and get him to do it. As far as this stuff goes, as far as I'm concerned, the rep is our bitch, and we need to ride the rep like a bitch, because that's his job. So, it's not strictly speaking official TAFE policy, but it's my policy. I don't size things, not when there's a rep. Okay, moving on from there. Sometimes, if we've got volumetric flow, we need to know what the mass flow was. The relationship between volumetric flow and mass flow is the relationship of the density. So that if you know the volume and you know the density, you can work out the mass. Let's have a quick squiz at what the next. Okay. The next bit of calculation is, if you have got a flow rate of 100 litres a minute, you need 500 litres. That means you open the valve for 5 minutes. Does that make sense? Just need to know. Okay, getting back to this, and sorry, microphone's got a problem again, but I think I'm back on. Right, if I'm considering some problems I may have with measuring flow. When I'm measuring flow with the majority of my flow meters, I'm actually measuring velocity. And from velocity, I'm calculating flow. Now, in order to calculate the velocity, to go from velocity to flow, I need to know the cross-sectional area. Calculation for cross-sectional area is cross-sectional area equals pi r squared. Here's my problem. I've got some air bubbles in the top of my pipe. If I've got 5% air bubbles in the top of my pipe, what error do I get in my cross-sectional area? Yep, you're right. 5%. Now, here's another problem. I've got crud in the bottom of my pipe. And it just sits there, builds up. Not very much. Let's just say 5% crud in the bottom of my pipe. What kind of error have I got in my flow measurement? Yeah, we're getting some pretty inaccurate flow measurement at the moment. Remember, I've spent $100,000 on this flow peak meter, and it's only 10% accurate right now. The fact is that with modern flow meters, the flow meter doesn't go wrong. Oh yeah, occasionally you'll get some electronics fault, but the flow meter is accurate. A modern flow meter is accurate. What goes wrong is the plumbing. What goes wrong is that we've plumbed it into the wrong place, and we've got air bubbles in the top, or we've got crud in the bottom. And that's where our errors are coming from. And this isn't a big lot of air bubbles, and it's not a big lot of crud, but we're already up to 10% error. If I was to say that in addition to all of this, I've also got scale build-up on the inside of the pipe, if I get 2 millimeters of scale build-up, I'm going to be getting near to another 10% error. So just very small amounts of scale build-up, very small air bubbles, very small amounts of crud in the bottom, and I'm getting massive errors. The important thing to know then, the important thing to remember is the flow meter is not wrong. What's wrong is the plumbing. Other things that can go wrong with the plumbing. We can put the flow meter in the wrong place. If flow goes round an elbow, normal flow profile just here, along the middle of the pipe here, we've got a nice, the flow meter should tell what's flowing through, but in actual fact the vast majority of our flow meters are measuring velocity. And if we from the velocity and the cross-sectional area, we calculate the flow. If the cross-sectional area is wrong, then the flow is wrong. The flow meter is reading the velocity correctly, but it's... Okay, now, here's another problem where the velocity can go completely wrong. Our flow meter measures velocity. The velocity is mostly in the middle of a pipe, so our flow meter is designed to measure across the middle of the pipe. If the flow meets an elbow, the fast-moving flow from the middle crashes through and ends up on the outside. We call it horseshoe flow. In actual fact, it's worse than it looks, because now we have all the flow on the outside here. On the inside of the elbow, the flow can actually go backwards. If we have a flow meter which is measuring velocity and it's sampling, say it's sampling in the middle of the pipe just here, if our flow meter is just sampling right bang smack in the middle of the pipe, just here, oh, that's the wrong colour, just here, oh, change colour here, just here, then it's going to measure a velocity of 0. In fact, if we're really unlucky, it might actually measure a negative velocity. It'll say the flow's going the wrong way. Now that is a big problem, especially if we're measuring. So the rule we always have is we say that we should have 10 clean diameters. So that's 10 clean diameters before the flow meter and 5 clean diameters after the flow meter. In actual fact, there are times when we need more than that. If we look at this extract from the installation manual of a flow meter, it tells us that if we have any sort of reduction in the pipe, we need to have 15 clean diameters before the flow meter. And it says 5 after. I'd still go for, sorry, it says 2 after. I'd still go with 5 afterwards. If we have an expansion in the pipe, once again, 15 clean diameters and 2 after. 1 elbow, they're now recommending a minimum of 15 clean diameters. 2 elbows, what happens with 2 elbows is we get horseshoe flow, which then meets the second elbow. Now we get a thing that's called annular flow. The flow is like a donut. All the flow is on the outside of the pipe. That's completely what we don't want. In this case, 2 elbows, 20 clean diameters before the flow meter. The very worst thing that we can do is have an elbow and then another elbow at right angles to it. Because what happens then is we end up with a swirling flow. The flow, oh, that's a bad colour, isn't it? Let's get that. If we have 2 elbows, the flow swirls. Now that completely messes up your average flow meter, because your average flow meter is looking for velocity. And it's going to see that swirl and say, oh yeah, there's loads of velocity here, therefore there must be loads of flow. Well, it's wrong. So if you've got 2 elbows at 90 degrees to each other, you have to have 35 clean pipe diameters. 35. If you have a valve after the flow meter, you need to have 8 clean diameters afterwards. So the 2 things that are going to mess up our flow meter are going to be things in the pipe, namely air or crud, or bends, elbows, reductions, stuff on the pipeline. What goes wrong with the flow meter is not the flow meter, it's the plumbing. We have to ensure that our flow meter is put into a good place. Just before we do the flow equations, I'm going to do another drawing. Sort of thing I mean is, if we have a pipe coming along, and then going up and over a roadway, and then back down and across, if we put the flow meter here, then it might suffer from crud. If we put the flow meter here, it might suffer from crud. If we put the flow meter here, then it might suffer from air bubbles. Probably one of the best places to put it would be here or here. We quite often, in this type of case, we quite often like to put the flow meter at the top where it's susceptible to air bubbles. If we're going to do that, then what we do is we put in a dog leg. And then we put the flow meter there. If you put the flow meter on a dog leg like that, then any crud in the pipe goes downwards, any air bubbles in the pipe go upwards, and providing we're a fair distance away from the elbow just here, the flow meter is going to be okay. This also ensures that the pipe never fills up with air. Some flow meters, especially magnetic flow meters, if they get air inside them, they go a bit crazy and they read just anything they want. So this is probably the best place to put your flow meter. It's a nice place to put it because also up in the air above a roadway, you're out of the way of the forklift truck drivers.